So when I'm not working on UKNOF stuff, which is most of the time, I'm working for an organization called DNS-OARC. What I want to talk to you about, OARC does a bunch of things. What I want to talk to you about today is about some work that my colleague Jerry Lindstrom, who can't speak because he's at the RIPE DNS hackathon today in Amsterdam. Some of the work that Jerry's been doing on a pile of software that we have accumulated over the past dozen years of OARC's existence that he's been kicking into shape and adding to over the past year or so. So what is OARC? The DNS is the place where names get turned into numbers, which sounds kind of boring on the internet, but actually there's a whole lot of interesting stuff goes on. It's almost like another layer in the protocol stack. OARC follows the model of many bodies that help glue the internet and internet operations together. It's a non-profit membership organization. What we're interested in is security, stability, and understanding. It's kind of like generating clue as much as distributing clue. So we work with researchers. We make their job easier. We do data collection from DNS operators and make that available between them and also to researchers. We do a whole bunch of tools. We do some services based on these tools. It's about relationship building, so it's exactly analogous to UKNOF, but with a more specialized international community. Information sharing, knowledge transfer. We run 2 workshops a year, which are, again, a little bit like UKNOF, but fewer people and rather more specialized and intensive. I'm just trying to make people understand that, whether or not you type a .com or a .uk into the end of your email address or your browser bar or not, the DNS is not going to go away. It's a very important part of the internet's architecture. And because it's important, it means that it's vulnerable to abuse. It's also a convenient mechanism for causing abuse by DNS amplification attacks. But because it's an interesting place to look, you can gather data. Here's some sample data that was gathered off our DSC system from one of the root operators in a fairly nasty attack that happened a bit over a year ago. And by learning from this stuff and analyzing it, working with researchers who can generate new insights, that's the way we can figure out what the problems are and how to solve them. Our members, there's a lot of household names there. You can see that there are a lot of country code top-level domain operators, so obviously Nominet, and then all the analogous organizations in Europe, South America, Asia. There's most of the major vendors of DNS software and regional internet registries that RIPE NCC, big ISPs like Comcast in the US, vendors of DNS appliances like Infoblox. We have somewhere around 100 members. The smaller members that you can't quite see there are also the researchers from quite a lot of academic institutions that are interested in security and DNS research. I'm not going to talk a lot about our governance. I feel that it's close to best practice in terms of how the industry and the works. Autonomous legal entity, which is non-profit status in the US. We do about $750,000 revenue per year, which is mostly from the membership subscriptions. The members elect a board. We have neutral self-governance structures. And that funds a staff of about half a dozen. Some of us are part-time. I spend about 3/4 of my time. Dinesh also has an evil alter ego. About 20% of his time is spent on OARC stuff in addition to what he does at UKNOF and elsewhere. We have a volunteer program committee and infrastructure in a number of places. We did a lot of stuff over the past year. Relocated our primary California site from the expensive side of Silicon Valley to the cheaper side of Silicon Valley. Because of concerns about diversity of the data and also surveillance issues, we made a copy of our data to another country. It's interesting when you ship a tens of terabyte data set across international borders in ways that you want to make sure that it's secure. We did our first workshop in South America last year, added considerably to our data storage capability. Every year we do something called the Day in the Life of the Internet. For 48 hours we gather a pile of data from the roots and other authoritative servers. We just completed that over the past couple of weeks. I think we've pulled in 6 terabytes so far, but that is still draining our way because it takes quite a time for it to come down from the root operators. But that's an archive that we have going back every year for over a decade. And we'll be doing a special couple of exercises. We quite often do this exercise every year, but we also do it when special events happen on the internet. As you may be aware, the zone size key used to sign the root with DNSSEC last year increased. And then later on this year, ICANN is going to roll the key signing key for the root for the first time. So we'll be doing a couple of collections for that as well. We updated our website, and as I say, it's been a real pleasure to have Jerry working with us for just over the past year. He's taken a lot of tools that we have accumulated and inherited over the years, cleaned them up, put them into a consistent build environment, and he started some interesting new projects as well. So this talk is very much about DNS software tools that you might use for better managing the DNS infrastructure you have on your network. In terms of the infrastructure, just say a little bit more about that. We're at Hurricane Electric in Fremont in California. We have a bunch of servers with significant storage capacity because a lot of the data that we have is basically too sensitive to stick in any third-party cloud. We have a little bit of peering. We have quite a lot of servers that do analysis, although we'd really like to build a proper analysis cluster with them. And the secondary site is in Ottawa. It's split by the .ca, top-level domain authority, CIRA, and also for some extra bandwidth, the Ottawa Internet Exchange. And that's a complete copy of what we have in the US. Hopefully we'll be able to boil it down to a single Canadian site at some point next year. We also have a little bit of diversity, a couple of servers that NetNode and Stockholm have been kind enough to donate to us. So, most of the software development environment lives in Stockholm, along with Jerry. Jerry has basically moved pretty much every single piece of code that we do onto GitHub. In general, although the data that we host is members only, part of our public benefit mission is to make sure that all the code that we use, certainly externally and with our members, and to some extent internally, is available in GitHub. He's using Autoconf, Automake, libtool, and a whole bunch of other automated tools to generate all the code. The code is all coverity scanned. And then we do builds which will work on 3 major Linux distributions and also the 2 BSD ones. And a new development that Jerry's added is that the Linux versions we're generating packages for as well. One piece of software that I've had for a long time is Domain Statistics Collector. And basically what this is doing is you can run it on your DNS servers or on a network segment adjacent to your DNS servers. Sniff the traffic, it then boils down this traffic into aggregate telemetry, stores the aggregated data, which can be then served up in a presenter, which may be local or remote. It's configurable. You know, it's a case of how much data do you want to capture off your servers. You can decide. This is the old style presenter that dates from over a decade ago. It was in-house development that was done by ISC and then inherited by OARC when OARC was spun off from ISC. And you can see that there's a whole bunch of breakdowns of the data that you can do by RR type or codes or various DNSSEC properties, and there's various ways of graphing it. For those of you who are used to using modern network management tools, you'll find it pretty old and clunky. So we decided last year that we wanted to evolve this. There's a tool called Grafana out there, which is a general purpose graphic presenter of data. A tool which basically migrates from the format that we use within regular DSC to the formats that Grafana was generated. And there's a demo site there which you're welcome to have a look at. The ways in which the visualization were improved, well, there's basically 2 use cases: running your network, or if you're a researcher and you want to try and understand what's going on with the data. One thing about Grafana is it's really only good at presenting time series data. Some of the data that we have doesn't fit well into a time series. So Jerry's having a look at Elastic Kibana to be able to generate more interesting tools with some of the non-time series analysis of the data. You know, for example, subnet allocation, geolocation. Yeah, so this is the kind of thing that you will see if you go to the demonstrator, or if you're interested in running this code with your. We used to run DSC as a service for our members. We still do, but we don't get a lot of data from them because they got kind of tired of using the old school tools. So we're doing some work at the moment to try and understand better from our members whether this is a service that we could usefully perform for them, or indeed for other parties. dsc-datatool, this is the tool that does the conversion from DSC, XML, and RAW formats. This exports to Graphite and InfluxDB. We're also looking at the CBOR format that is an ITF standard recently, but there are some unclear intellectual property issues surrounding that due to a large organization not far from here. Not quite doing that, but basically it's a flexible way of converting tools, and there's various types of transformations and generations you can do in that. So that's where the test site is. Welcome to have a look. It uses live data from some of our internal traffic, and there's documentation on how to set that up. Another tool that OARC has is DNSCAP. So you may be familiar with PCAP files that are generated by TCP dump or similar tools. DNSCAP understands the semantics and nature of DNS traffic at a deeper level than TCP dump. So basically you use it, wire capture DNS packets for whatever application you may want. We happen to use it for our day in the life of the internet data collection, but that's by no means the only use from it. It's code that's kind of kicked around in a slightly orphan status for a number of years, but we formally transferred the ownership of the code from ISC to OARC last year, which is good, and we're grateful to ISC for that. So that's DNSCAP. And so that's some of the existing tools that we've been working on and getting them into shape. We've also started some new tools. Some of you may be familiar with Netalyzer as a tool for, you go to the web page or you run the Java application and it tells you a whole bunch of useful stuff about your internet connection. Check My DNS is kind of like that, but it's specialized for the DNS. So you go to the web page of the tool, it fires a whole load of packets between your client resolver and the tester. There's an API interface in there, and it tests for a whole bunch of things like, is there a proper IPv6 path for Quad A packets? Will DNSSEC traffic get through? Are there any particular things about the DNSSEC implementation at either end that you need to worry about? Is QNAME minimization supported? Is DNS over TCP traffic properly allowed through? What we do with a lot of these testers, we have a whole bunch of them, of which this is just the newest, is that as well as making the results available to the people that are using it, we store the results. In the past, there have been particular issues and vulnerabilities to the DNS. Some of you may remember the Kaminsky vulnerability. When you have people using a tester to check a particular issue, if you keep that data, then you can, over time, measure the extent to which the vulnerability is being mitigated or workarounds are going in place. So it's very clear that if you use our testers, then your data will not be made public, but you shouldn't regard it as private either. Whole bunch of future tests that we want to add to Check My DNS, check reply set. We have some existing testers, reply size, DNS entropy. On the old testers, what Check My DNS is a kind of pluggable architecture for a whole bunch of all of these tests. So we'll consolidate all these ad hoc little testers into the same pluggable architecture, and that will make it extensible because you can guarantee the complexities of the DNS protocol mean that there will be funky new stuff coming down the line. So there's a whole bunch of things that cause headaches in an operational environment that this thing can check for and measure and analyze. Here's what Check My DNS looks like. Again, there's a test version that you can go look at. It basically shows the counts of the packets that have been exchanged in order to do the tests. The results of the various tests you can drill down in detail, as well as seeing the overview on the right-hand side of the screen. software engineers love to refactor stuff they've already done. So at the moment, this is being re-implemented in Go, which is this year's language. It has already significantly increased the performance, and it will also potentially make it portable to run at multiple locations. And the idea is ultimately this could be a website plugin that you could use to see how your visitor's DNS is accessing what you're doing. The other tool that's new, we're grateful to Comcast for funding this under their Innovation Fund, is called Drool. And software for that just dribbled out. DNS Replay Tool. And what this does is once you've done a whole load of packet capture, maybe you have an attack or maybe you have an interoperability issue, you capture the packet using PCAP, your preferred PCAP tool. What Drool can do is it can replay these packets. And it doesn't just like dumb replay them, you can manipulate the timing so that the inter-arrival time of the packets is maybe the same as originally captured or different, or you can just take a pile of packets and hammer a target with them. Or you can repeat or do any iterations. So Comcast told us this is something they would find really useful in both their test and production environments. So we have made the beta release of this has been available recently, and we're hoping to develop more. The other thing that some members have expressed interest in is, wouldn't it be nice to have some sample traffic? And we thought, well, yeah, it would be nice to have sample attack traffic, but making that available to the public is kind of like selling chainsaws to kids, really. So that is something, if we do, we'll probably limit to members so that we're not actually giving attackers tools that they can use. Here's a sort of sample drool run, it's command line based, but I'm sure that people will come up with many creative uses for this. The other thing that came up with to help with the drool testing was DumDumD, which is just basically a high capacity traffic sink. I suspect that this will have many more uses than just DNS specific ones. But if you want to get rid of 1 million packets per second, then this is your tool. As I said, the history is we had a whole bunch of ad hoc tools, and there's been duplication, lack of modularity, so a lot of work has been going into cleaning all of this up and building some helping libraries, PCAP thread support, various tools for parsing configuration and managing it. So that is, again, also something that's available in OARC's GitHub site. We have, as I say, workshops twice a year. Usually these have about 100 to 150 people attending. We tend to co-locate them with the big international operations meetings, so RIPE, NANOG, usually one of these each a year. Also IETF and ICANN meetings. We're doing something a little bit different this time. Instead of locating our European meeting with RIPE in space, it's consecutive in time, but immediately after RIPE 74 in Budapest, we're having OARC 26 in Madrid. And the reason we're having it in Madrid is that ICANN is having a new cluster of operationally relevant meetings, so they're taking things like their existing GDD meeting, their registry operations workshop, a new DNS symposium event. So that adds up to about 5 days. You will find something strangely familiar about the event sites that we use. If you go to OARC's Indigo site, you can find more about the Madrid meeting, which has got about, the agenda has been published last week, and the discounted registration for non-members continues until the end of the month. Later in the year, if the wall doesn't go up, then we will be in San Jose. We like to co-locate with NANOG. It generally works well. So we'll be in Silicon Valley immediately before the NANOG meetings and the RN meetings. That's what we're doing later in the year. So because we're a non-profit, I'm going to pitch to you, why should you become an OARC member? It's not for everybody. You need to have a reasonable DNS focus for it to be worth your while. But we have a community of the people who really know the DNS and they know about how to make it work operationally. So you get to be in the room with them. We need to get funding to keep all of this cool development work working. So fund that. You get useful tools which will help your infrastructure and how you run your DNS operations. And we have, about 100 terabytes of data that has been gathered from our various test tools or various collection exercises. I don't really think there's anything else like it in the world. We found that data gathered many years ago has turned out to be the only way to actually analyze a current problem. ICANN funded a thing called the CDAR study last year, which was basically trying to figure out, well, there's all these new GTLDs that keep getting added. What are the possible consequences? So we really had the only data set that went far back in time and could provide that. And it's interesting. It was like one of the more interesting conclusions I thought was, well, it's not the creation of all these domains that's creating a problem. It's like now they've been created, what happens if some of them go away? Otherwise, it's not breaking the internet, which I thought was interesting. When incidents and threats happens, we have various resources, mailing lists, chat rooms, some other tools and also just the fact that the people who have to deal with these threats that are more than one provider wide can work together. And we're neutral. We do our best to run an organization that you can trust, and we don't represent any particular vested commercial or government interests. We try and work for the internet as a whole. And that's basically it. I'd be happy to take any questions.
Thank you, Keith.
Thanks, Keith. And we have got time for questions. I'm going to make a question up really quickly. Drool, dum-dum-dee. Where's your naming policy coming from? What?
Oh, I reckon that Jerry goes out drinking with the Swedish chef from the Muppets or something like that. He'll kill me for saying that.
Drinking in Sweden, that's a pricey business, isn't it?
Curtis will kill me for saying that. Yeah, well, you got to have fun with naming. Well, we're in the DNS business, we have to have fun with naming.
Yeah, well, true, yeah. Are there any questions? If not, then thank you very much, Keith. Thanks for your semi-regular update on activities of DNS-OARC.